This is a video on the line of intersection. The question states, find symmetric equations of the tangent line to the curve of intersection of the surfaces at the point 2, -1, 1. And the surfaces are defined by y plus 2xz equals 3 and 2x minus yz equals 5. So here's the strategy. We want to find the symmetric equations to the tangent line to the curve of intersection. The tangent line to the curve of intersection of the two surfaces will lie on both tangent planes to the surfaces at the point. The normal vector to the tangent planes is perpendicular to any line that lies on the tangent plane. So if we have two different normal vectors that are perpendicular to a particular line, we can find a perpendicular vector by taking the cross product of those two normal vectors. So let's start out by finding the gradient of the two surfaces, because the gradient will always be parallel to the normal vector. So I find the gradient of the first surface. The partial derivative with respect to x is 2z. The partial derivative with respect to y is 1. And the partial derivative with respect to z is 2x. For the second surface, I get the gradient vector is 2, comma, negative z, comma, negative y. So I plug in the point 2, negative 1, 1 into each of these gradient vectors. And that'll give me my first normal vector. Z is 1, 2 times 1 is 2. Still have the 1. X is 2, 2 times 2 is 4. So the first normal vector is 2, 1, 4. The second normal vector I plug in. I still have the 2. Z is 1, so negative z is negative 1. Y is negative 1, so negative y is positive 1. So those are my two normal vectors. To find a vector that's parallel to the tangent line of the curve of intersection to the surfaces at the point, I just take the cross product of the normal vectors. So I take the cross product of n1 and n2. So I write down the matrix IJK, 2, 1, 4, and 2, negative 1, 1. So I work that out. For the I component, 1 times 1 is 1. 4 times negative 1 is negative 4. 1 minus negative 4 is 5. So I get 5i. For the j component, 2 times 1 is 2. 4 times 2 is 8. 2 minus 8 is negative 6. And for the j component, I switch the sign, and I get plus 6j. Now for the k component, 2 times negative 1 is negative 2. 1 times 2 is 2. Negative 2 minus 2 is negative 4. So I get negative 4k. So I can say that the tangent line to the curve of intersection is parallel to the vector 5i plus 6j minus 4k. So now that I have a parallel vector to the line, and I have a point on the line, I can just plug these into the formula for symmetric equations. And I get my final answer, that the symmetric equations to the tangent line to the curve of intersection of the surfaces at the point 2, negative 1, 1 is x minus 2 over 5 is equal to y minus negative 1, or y plus 1, over 6, which is equal to z minus 1 over negative 4. And I'm done with the problem.